So today we discuss about today we complete this chapter. Okay. So metals of medium reactivity, okay, or middle reactivity series elements. So you know that metals are three types of them. One are highly reactivity, second are called medium reactivity or moderate reactivity, and third one are called low reactivity. Okay. So the metals which comes under high reactivity are what? Sodium, magnesium, calcium, potassium. These comes under the metals of high reactivity. Okay, and these metals can be extracted by the process called electrolysis. By the process called electrolysis that we discussed in the last class. Okay, now one come to the second one. Second type of metals are what? The metals of moderate reactivity. So this moderate reactivity, which type of metals comes here? Like zinc. Okay, so like zinc, it comes under the moderate reactivity. Okay, so moderate reactivity metals, how they can be extracted. Okay, that we are going to learn here. Okay, so moderate reactivity or middle reactivity elements, which elements? Like zinc, iron, lead, copper. This all we can give an examples for the medium reactivity or middle reactivity series. So you can see on the slide here. So see here, the metals of middle reactivity series are iron, zinc, lead, copper. These are some of the metals which okay, comes under the moderate or middle reactivity series. Okay, now how can we extract these metals? So see here, Avinash, these middle reactivity series elements are mostly available in the form of sulfides or carbonates. In which form they are available? They do not available in the nature as it is. For example, if you take the zinc, we do not get the zinc as it is in the nature. Okay. If you want to take iron, you do not get the iron as it is. So these metals already we discussed. These metals will be available in the combined state. Okay. The mixed state they are available. Means they combine with other elements they are available. And here most of the middle active series metals are available in the form of sulfides and carbonates. In which forms?
Sulfides and carbonates.
Right. So here sulfides and carbonates in nature. These are usually present in the form of sulfides and carbonates. Okay. So now if we want to extract them, okay. Now if we want to extract them, means like sulfides, they are getting in the form of sulfide or carbonate. So here some steps are involved here. Okay. Some steps are involved. The first step is that these sulfides or carbonates are converted into oxides. Oxides. So again in converting into the oxide, two methods are there. For sulfides, what we do? We convert them into oxides by the process called roasting. By the process called? Roasting. And other ones are what? Carbonate ores. Carbonate ores are converted into oxides by process called calcination. What is the process? Calcination. So here what is the difference between these two is roasting means heating of ore in presence of air or in presence of oxygen. Okay. So we provide the oxygen, in presence of oxygen we heat, that is called roasting. And calcination means what? The heating of ore in absence of oxygen. Means what? Without oxygen. In absence of oxygen. That is called calcination. Is this clear to you? So sulfide ores are subjected to roasting. Means what? In presence of oxygen they are heated. And carbonates or ores are heated in absence of oxygen. That process is called calcination. By this process, we convert these zinc sulfides or carbonates into oxides. Okay. Now, once you see on the slides here, see here, the sulfide ore are converted into oxide by heating in presence of air. By heating in presence of air, and this process is called roasting. Is this clear? Now see carbonate ore. The carbonate ore are converted into same oxides, but here limited amount of air or very less air or no air also. And this process is called calcination. What it's called? Right. Now we are taking, for example, zinc. We are taking here how zinc is extracted. So see here, zinc we can get in two forms. One is called as a zinc sulfide. Second one is called as a zinc carbonate. Okay, zinc sulfide and zinc carbonate. They are available in the form of zinc sulfides and zinc carbonates. So now zinc sulfide should be converted into zinc oxides. Here we are converting into zinc oxide. Similarly, zinc carbonate we are converting into zinc oxide. So or whatever it may be sulfide or it may be carbonate, we have to convert them into oxygen. We have to convert them into oxides. Is this clear? So now zinc sulfide, see, in presence of oxygen, see here, in presence of oxygen, so we are supplying oxygen. In presence of oxygen, when we heat it, then we can get the zinc oxide and the sulfur dioxide gas. It's a gas, it escapes and we left with the zinc oxide. Okay. Now here you see zinc carbonate. So here I said no air. In absence of air or limited supply of air, here we are not supplying any oxygen. See, here we are supplying oxygen. Here you see 3O2, but here we are not supplying oxygen. So without oxygen we are heating. So then what happens? Because zinc carbonate is decomposing, means what? Splitting into zinc oxide and carbon dioxide. Carbon dioxide will escape, it's a gas. Now left with water, zinc oxide. Now in both the cases we see, we converted the sulfide and carbonates into oxides. Is this clear to you? This is the first step. This is what the first step. Now second step, what we do? Now along with the zinc they have oxygen, but we want only metal. We want only metal, we want only zinc only we want. We don't want oxygen, we want only metal. So now what we have to do? We have to remove the oxygen from that oxides. Yes or no? From zinc oxide, we have to remove the oxygen so that we can get the zinc. Is this clear? Yes. Am I audible to you? Okay. So now we have to remove the oxygen. Okay. The process of removing oxygen is called the reduction. Do you know this word reduction? There are two words are there in the chemistry. One is called, two terms are there. One is called oxidation, second one is called reduction. Addition of oxygen is called oxidation. Removal of oxygen is called reduction. So addition of oxygen is called oxidation. Removal of oxygen is called reduction. So we have here zinc oxide. Here also we have the zinc oxide. Here also we have the zinc oxide. But we need only zinc. Only zinc we need. Only zinc we need. Okay. So what we have to do? We have to remove the oxygen. Yes or no? We have to remove the oxygen. So removal of oxygen is called what? Reduction. What it's called? Reduction. So if I ask from the zinc oxide oxygen come out, means whether the oxygen will come out? No. So we have to heat that zinc oxide with some reducing material. Okay. Some other material we have to use and we heat. So that's what we are doing is the zinc oxide what we get here, that we am taking here and I am heating in presence of carbon. So we are mixing with the carbon and I am heating. Carbon powder I am mixing to this one, I am heating. Then what happens? This carbon react with this oxygen. See here, this carbon reacting with oxygen to form a carbon monoxide. Means what? Carbon is taking the oxygen. Carbon is taking the oxygen. So now we are getting the carbon monoxide. So this is a gas. So see G is there, means gas. It will escape. Now from the zinc oxide, this carbon is taking the oxygen. Now what is left here now? From the zinc oxide, carbon is taking out the oxygen. Now what is left here? Zinc. So zinc is left. So this is the required metal what we want. Okay. In this way we extract the metal. And but this metal is not pure. Okay. This metal is not completely pure and it can be purified by electrolytic reduction. Which method? By electrolytic reduction we can get the pure metal. So this is about the extraction of metals of middle activity series. Is this clear?
Yes, sir.
Once again, I'll explain, listen carefully. So here, middle active elements can be, okay, like examples of middle active elements are like zinc, iron, lead, copper. These all comes under the middle active series elements, and these elements are mostly available in the form of sulfides and carbonates. And here, to extract them, first these sulfides and carbonates should be converted into oxides. To convert them into oxides, for sulfide ores, we are heating in presence of oxygen, and for carbonate ores, in absence of oxygen. So, if you are heating in presence of oxygen, that is called roasting, and if you are heating in absence of oxygen, that is called as a calcination. So, by the process called roasting, we convert the sulfide ores into oxide ores. By process called calcination, carbonates are converted into oxides. That is the first step. In the second step, from the oxides we reduce. Okay, so by heating with the carbon, so the carbon reduces, means carbon take out the oxygen from the zinc and it forms the carbon monoxide by leaving the zinc alone. So we can get the zinc metal. Okay, and this metal is not completely pure. So to purify it, we use the electrolytic reduction. Okay, to get the pure zinc. Is this clear to you?
Yes, sir.
Take the screenshot of this one. Have you taken?
Yes, sir.
Okay. Now let's go to the next slide. So this you understood now? Right. So this is refining. Just I told you, refining of means purification. So when you extract the metal, whatever the metal we get, that may not be 100% purified. It's not 100% purified. So it consists of some impurities. The impurities, we use this method. So this is called the electrolytic refining. What it is called? Electrolytic refining. Okay. So in this method, you see these many metals like copper, zinc, tin, nickel, silver, gold, all can be refined by this method. Okay. So here example it is given here, electrolytic refining of copper. Here how can we purify the copper? Okay. So for that the electrolytic solution is an acidic copper sulfate. So here you can see this solution is there, the blue color solution is, this blue color solution is okay, copper sulfate solution. What it is? If you are purifying, you have to take copper sulfate solution. If you are purifying some, what do you say, zinc, then you take zinc sulfate solution. Like this, which metal you are purifying, that metal solution you have to take. Okay, so like this is a copper sulfate solution. So here, acidified copper sulfate solution. Acidified means what? Small amount of acid is added because to increase the conductivity. To increase the conductivity means what? To pass the electricity easily. Okay, then we take the two electrodes. You know about the electrodes. So these are the electrodes. In that one is called a cathode, which is connected to the negative terminal is called cathode, which is connected to the positive terminal is called a anode. Now this anode is, this anode is taken as impure. Okay, impure copper is taken. What is taken? Anode here is this here. Impure is taken as water. Okay, anode, and cathode is made up of pure copper. Okay, so cathode is made up of water, pure copper. Here the cathode is a strip of pure copper. Now on passing electricity, what happens? Okay, all the pure copper will be deposited on this cathode. Okay, by leaving the impurities down. So you can see here the down. Can you see here? So this is the impurities. So in this way, impurities will be removed, and we get the pure metal. So this is called as a refining of metal. This is what?
Refining of metal.
Right, very good. Refining of metal. So take the screenshot of this one also. Sure. Now we are coming to most important topic, that is called corrosion. What is the corrosion? Do you know what is the corrosion?
No, sir.
No. So, for example, you take one iron nail from the shop. You purchase one iron nail from the shop. So, when you purchase iron nail in the shop, how it would be? Like it is shiny, because metal, no, metals are what is it? Lustrous. Okay, lustrous means what? They are shiny. Okay, now keep that iron nail outside in your garden. Okay, back side of your house there will be a garden, no? So in that garden, okay, you just throw it, and after a few days, take that iron and see, is it whether it will be shiny now?
No, sir.
Why?
Because the outside gases react with
So now what it forms on it? What we call it as?
corrosion.
That's called rust. Do you know the rust?
Yes, sir.
So iron will get rusted. If you see the iron windows, iron grills, iron things, whenever you can see outside somewhere, so you can see all red color coating is formed on it. Yes? That is called rusting. What it is called? Rusting. And that rusting is nothing but a corrosion. Rusting is a part of corrosion. If the iron undergoes the corrosion, then we call it as a rusting. Is this clear to you? So like this, if you take not only iron, most of the metals will get rusted. For example, take the silver articles. Silver, you know, no silver, okay, that will be white and shiny. So those silver articles also, if you don't wash them, and if you don't clean them, and you don't pack, okay, and if you keep outside somewhere, okay, and then what happens after few days, that get a black color coating is formed on it. What is formed on it? A black color coating is formed on it, and this black color coating is called as a, what is that? Silver sulfide. That is also called a, okay, corrosion. Is this clear, corrosion?
Yes, sir.
Similarly, if you take the copper vessels also within a copper. So copper vessels also, if you keep a few days outside in the moisture and somewhere, then what happens? They become green in color. They become green in color. This is also called as a corrosion. Okay, so that what is this green color is formed on it? That is called copper carbonate. What is formed here?
Copper carbonate.
So that is green in color. And you know that iron, the red color substance is formed, that is called as a rusting. So these all are part of a corrosion. The meaning of corrosion means what? So actually the metals are reactive. Metals are reactive. So they can react with other elements. Okay, they are electropositive, so they are reactive. So due to that, what happens? They are reacting with the atmospheric gases in presence of oxygen. In the atmosphere, oxygen is there. In atmosphere, carbon dioxide is there. Sulfur dioxide, the number of gases are there, and even moisture, water vapor is also there. So due to this, what happens? They react with all these atmospheric gases and moisture. Then what happens? They get corroded. Okay, so due to corrosion, what happens? That metal get destroyed. Okay, so this process is called as a corrosion. Okay, so here you see here. Okay, silver articles become black after some time when exposed to air. Okay, silver articles becomes black when exposed to air. This is because it reacts with the sulfur in the air to form the coating called silver or silver sulfide. Very important. So this type of questions you'll get in the next examination. When you have a next exam, the chapter will be from metals and non-metals, and tomorrow I'm going to, in the next class, I'm going to start the new chapter. So these are very important. So silver articles becomes black. This is most important. The black substance is due to what? The silver sulfide. Due to what? Silver sulfide. Right? Next. Yeah. Now see here, copper react with moisture carbon dioxide. So it's reacting with carbon dioxide, and it forms a green color substance. Okay, what it forms? A green color substance, so green coating, and this green color substance is called copper carbonate. What it is called?
Copper carbonate.
Copper carbonate. Okay. Similarly, iron when exposed to the moist air, iron is exposed to moist air. Moist means what? Wet air. So here also a brown color coating is formed, and this is called rust. What it's called? These are the corrosion. So corrosion, due to corrosion, what happens? The metal gets spoiled. Okay. So many bridges, if you see, which are made up of metal, they Okay, after few years they get damaged and they get collapsed. That is why, that is due to the corrosion. Okay, so to prevent from corrosion, what we have to do you know what you have to do to prevent from the corrosion? If you want to protect the metal, you have a window. For example, in your house there is a window which is made up of iron grill. So how can you protect it?
Glass.
Huh? Once you see your window, just if you have around your window, just once you see how window, if a grill, if it is made up of iron, can you see the iron?
Yes, sir.
What you can see? What you can see?
Sir?
What you can see in the window grill?
Yes. Iron designs.
Iron design. But what is the color of your window? Now grill color.
Some green and yellow.
So the meaning is what you painted on it. What you did?
Painted.
So generally whenever you take the iron grills, you fix to the windows, then what happens, immediately we paint them. Okay, if you don't paint, that get rusted, and that gets spoiled. All brown flaky substance will form, and all it will, after few years it will get damaged. So whenever you bring any iron article in your to home, then immediately what we do, we paint them. Okay, so this painting layer, what it will do, this paint will protect the iron to not reacting with the atmosphere. One paint layer will be there. No, this paint is protect the iron for reacting with the atmospheric gases. Is this clear? So can you protect only by painting? No, there are other methods also there. If there is no painting, you can apply the oil also. What you can apply? Oil or grease. Oil or grease also will protect the metals. Okay, or what can we do? Or we can coating with the zinc. Okay, that's called galvanizing. Or we can alloying. Alloying means what? Mixing of metals. Alloying means what?
Mixing of metals.
Mixing of metals and non-metals. Okay, that's called alloying. For example, in your house there are the stainless steel vessels are there. Stainless steel glass, stainless steel tiffin boxes, stainless steel plates. Okay, will be there. So the stainless steel, main component of the stainless steel is nothing but iron. The stainless steel, most of the component is what is present? Iron. But it's not getting rusted. Is it getting rusted? No, because that is alloyed. Alloyed means what? That is mixed with the iron, is mixed with some other materials like chromium, manganese and etc. So that that is becoming the same stainless steel. Now stainless steel will not get rusted. Okay, so that is called alloying. What it's called? Acha, take the screenshot of this one first. Okay. So this is called alloying. So here you can see how can you prevent the corrosion. So how can we prevent the corrosion? See, just now I told you that the rusting of iron can be prevented by painting, by oiling, by greasing, by galvanizing, or by chromoplating, anodizing, or by making alloys. These all are the methods by which we can prevent the rusting. Is this clear?
Yes, sir.
So what are the methods here? So rusting of iron can be prevented by painting. Just you paint it. If there is no paint, then oiling means apply the oil. If not, greasing. Grease means nothing but like oiling. And galvanizing means what? Copper plating and chrome plating, like this, or alloying. So galvanization means what? Is a method of protecting the steel or iron from rusting by coating. See here, by coating them with a thin layer of zinc. Remember here, this is a very important point here. Galvanizing means what? The coating the iron articles with zinc. Okay, that is called as a galvanizing. Is this clear?
Yes, sir.
Next, Alloying. Alloying means just I told you know, alloy means what? A homogeneous mixture of two or more metals or metal and non-metal. So to protect the iron from rusting, okay, then what we do? We mix it with some other metal or sometimes non-metal also mixed. So the homogeneous mixture of metal and metal or metal and non-metal is called as the alloy. Okay, alloying. Okay, so alloying is very good method improving the properties of metal. So alloying protects the metal from corrosion. Is this clear to you?
Yes, sir.
Now see here, when iron mixed with the nickel, chromium, then we can get the stainless steel. Just now I told you know stainless steel. So stainless steel means what? Whatever the plate we used to eat, tiffin boxes we carry to school or anything, and we have the water, drinking glasses, water glasses. These all are made up of stainless steel, and they are kept in water. The water is stored in that, but still they are not getting rusted. Why? Because they are alloyed. Alloyed means what? Mixed with some other metals. So metals like nickel, chromium, okay, like this they alloyed. Is this clear? So this by mixing nickel and chromium to the iron, we can get the stainless steel, and stainless steel is hard and does not rust. It does not rust. Is this clear?
Yes, sir.
Like this some other alloys also say brass. Okay, brass is made up of copper and zinc. So when you mix the copper and zinc together, we can get the brass. Similarly, another alloy is what? Bronze. Bronze is the alloy of copper and tin. If you mix the copper and tin, we can get the bronze. So these are the alloys. So alloys are the mixed with the metals to protect from the corrosion and also to improve the properties of the metal. To also improve the properties of metal. So this is called as a alloying. And you see one more alloy is solder. Solder is an alloy, so which is made up of tin and lead. It is made up of what? Tin and lead, and it is used for low melting, for welding purposes it is used. For what purpose it is used?
Melting.
Welding, you know, it's joining.
Yes, sir.
Welding purposes we use. So, and here sometimes you see mercury is also mixed with metals. Mercury is also mixed with metals. When you mix with any metal, then that is called amalgam. What it is called? Amalgam. So these all are examples for the alloys, and these all are the methods to prevention of corrosion. For what purpose they are using? To prevent the corrosion. Is this clear?
Yes, sir.
So with this the total chapter is done. So with this metals and non-metals chapter is done. Now, so I think as of now, what are the chapters we completed? Once let me check.
Structure of an atom, metals and non-metals, and structure of an atom, and language of chemistry, sir.
Language of chemistry we did, structure of atom we did, metals and non-metals also we are completed. Yes?
Yes, sir.
So the next topic is coal and petroleum.
Yes, sir.
So in the next week, means in the next class, I will start the coal and petroleum chapter to you. Otherwise, I will briefly, I will discuss once again with this chapter. So now we will have only two chapters, that is coal and petroleum, and the next one is the synthetic fibers and plastics.
So matter around us,
Matter around us is not there this year, so we take in the next year.
Okay, sir.
When you come to the 9th class, at that time we take the matter around us.
Okay, sir.
So we take coal and petroleum, and synthetic fiber and plastics we take.
Okay, sir.
So take the screenshot of this one, prevention of corrosion also once. Chalo. So with this we done today, And in the next class, tomorrow or day after tomorrow, when we have next class?
I don't know.
Yeah, okay then, no issue. Okay, so shall we stop the class now today, for today?
Yes.
Right, bye.